Richard Feynman once said that what we're really searching for is how everything works. Not just what things are called, not just how they appear, but what makes them move, what makes them interact, what makes the world function at its deepest level. For Feynman, understanding wasn't about memorizing answers, it was about asking better questions. What makes something do something? Why does the wind move the way it does? Why do waves rise and fall in patterns? Why does sand form ripples that look strangely familiar? Most people see these as separate things: water, air, earth, different elements, different behaviors. But Feynman saw something else. He saw repetition. The motion of water is like the motion of air. The currents in the ocean mirror the currents in the atmosphere. The patterns in sand dunes echo the patterns in waves. Different materials, different scales, the same underlying mathematics, the same invisible principles at work. And that realization changes everything, because suddenly the world is no longer a collection of random events. It becomes unified. One system, one structure, one set of rules expressing itself in infinite forms. The deeper you look, the more universal it becomes. At first, it feels almost unbelievable. How can something so complex be governed by patterns so simple? But that was the beauty Feynman loved. The truth isn't complicated in the way we imagine. It's remarkable. It's elegant. It's astonishingly consistent. The difficulty isn't in nature. It's in how we look at it. Feynman believed you have to look at the world as if you've never seen it before, to strip away assumptions, to forget what you think you know, to approach reality like a beginner. Because when you do that, you start seeing connections everywhere. You begin to realize that the same principles govern the falling of an apple, the orbit of the moon, the swirl of cream in your coffee, and the formation of galaxies. It's almost poetic. The universe doesn't reinvent itself for every phenomenon. It repeats itself again and again, across scales, across forms, across time. And that repetition, that deep unity, is what makes understanding possible. But none of this begins with equations. It begins with curiosity, that simple, stubborn instinct to ask why. Why does this happen? Why does it move that way? What's really going on underneath? Curiosity is what forces you to look twice, to question what everyone else accepts, to refuse shallow explanations. For Feynman, curiosity wasn't optional. It was identity. It was who he was. Just like a runner gets a rush from pushing their limits, from feeling the burn in their muscles, from crossing a finish line, Feynman got that same rush from thinking, from discovering, from seeing something clearly that was once confusing. He described it as a kick, a thrill, an almost physical pleasure in understanding something deeply. And once you experience that, you can't stop, because curiosity doesn't fade when it finds an answer. It grows. Each answer creates new questions. Each discovery reveals deeper layers. And the world becomes more alive, not less, more mysterious, not less, more beautiful, not less. That's what makes everything work, not just the laws of nature, but the human drive to uncover them. At the heart of science, at the heart of progress, at the heart of Feynman's life was curiosity. The willingness to see the world from another point of view, to look at the ordinary and find the extraordinary, to realize that the motion of waves, the motion of air, the motion of sand are whispers of the same deeper story. And once you start listening, you can't unhear it. It's curiosity. And in the end, it's who we are.